All right. Hello, everyone. Let's get started. My name is Moritz Eckert. I'm part of the team at Edgeless Systems. We are a startup from Bochum, Germany, and we build open source software for a technology called confidential computing. Who of you knows or has heard of confidential computing? Please raise your hand. Oh, a lot of hands. If you don't worry. I'll start off with a gentle introduction to the topic. But in particular, I want to look at a specific use case for confidential computing today, which is the public sector, the healthcare, the finance, telco, all those regulated industries and their journey to the public cloud. I'm not sure if anybody works here in such industry or has experience with the problem at hand, but usually and I'm not going to go into the why, when we have workloads in these sectors and we want to move them to the cloud, there's a lot of hurdles, right? There's a lot of regulation that makes it either very difficult or impossible to run that stuff in the cloud, right? And the reasons are fundamentally privacy and security concerns, and there's fundamental laws such as the GDPR that simply prevents us from processing this sensitive information in a untrusted environment. And I heard a very good analogy this week. If you process something on the public cloud, it's a bit like renting a flat, where you have a landlord and owner of that apartment, and they have a key. They shouldn't, or they're probably not allowed to access that apartment, and usually they don't, but they could, right? And it's similar in the cloud. We have an environment where we are not sure who has access to our workload, our data. And this is why it's so difficult. And then there's regulation for specific industries, such as the financial sector, where we have the BaFin with very strict requirements. We have healthcare, think of applications such as the electronic health records, where the Gematik makes very specific requirements how we process that data. And the reality is that for those use cases, usually things stay either on-prem or in a private data center, private cloud scenario. The question, and what we're going to look at in this talk, is can confidential computing be a technology to help with this specific problem? And interestingly, I found also last week in the Bitkom guideline for cloud computing, there's this sentence pretty much says in the future there will be a requirement that we have something like privacy by design or by software design that includes encryption if we want to move regulated, sensitive applications and data into the cloud. And this is pretty much precisely what confidential computing is going at. Because confidential computing tries to close, or not tries, it closes the gap of how we can encrypt data. Right now we can encrypt data while it's at rest, while it's in transit. With confidential computing, we want to close this gap to also protect data while it's in use. Because this is precisely what's happening if we move something to the cloud. This data is processed there in plain text. And if we can keep it encrypted inside this processing step, we have encrypted at all times, and there's no gap anymore. And the invariant here is that if we process encrypted data, it's equivalent to processing anonymized data. Right? This is the invariant we have. And once we do that, it can be an unblocker for this cloud scenario. So that's the idea. Always encrypted processing by protecting also the in-use. So how does confidential computing achieve this? We're not talking about operating on encrypted data. This would be homomorphic encryption. This is a different topic. Confidential computing is fundamentally a hardware-based solution to this problem. So an extension to the processors, to the CPU, that allows us to keep the data of an application, or also the application itself, encrypted in main memory and isolated from the rest of its environment. So if you think about the cloud stack, usually a virtualized environment, what the new technology allows us to do is basically let the hypervisor talk to the processor and say, hey, please create me a new VM and keep the memory of this VM encrypted. This means the hypervisor or any other VM, they cannot access this memory space because it's encrypted, and the CPU is some of like the gatekeeper that ensures only the guest inside this VM can access the memory pages. And inside this VM, we operate on the plain text data. This means there's almost or only a negligible overhead in terms of performance. But from the outside, it's a black box. We cannot peek inside, and it's encrypted, so even physical access will not leak our data. And this is provided by the latest server CPUs from AMD, from Intel. There's also an ARM specification that pretty much provide us with this hardware feature to keep our VMs isolated and encrypted while they are running. Now, what does this mean for our cloud model? It means, right, we leave this. Think about the apartment analogy, right, where we have to trust the entire stack below to not access our data. Now, this changes it fundamentally so that we can cut off, and we only trust our gatekeeper, our CPU, our hardware processor, and our workload that exists inside this isolated environment. And the rest of the stack is outside of this trust boundary. And the analogy goes further and says this is somewhat of like an embassy in a foreign country, right, where you have a gate and nobody can access this embassy. And what we do inside is protected, even though we are in a potentially hostile environment. So the question is that already relevant for regulation, right? If we can change the trust model of the cloud, is it relevant? And we see, yes, the Gematik already adapted this for their specification for things such as the electronic health records or the e-prescription. They use this kind of technology for providing what they call vertrauenswürdige Ausführungsumgebung, essentially a trusted execution environment. And also we see that the financial industry, there's the Digital Operations Resilience Act on the horizon. They also specify encryption not only in transit and at rest, but also in use. And yeah, lately also the BSI is looking at confidential computing as a potential unblocker for precisely the regulated industries. All right, beyond regulation, of course, this is also interesting if you just move any kind of sensitive workload to the cloud, if you think about software as a service and very hard tenant isolation, all of this is benefiting from this new model of operations. And a very particular case would be large language models, right? Think about using ChatGPT without needing to trust Microsoft or OpenAI or anything in between. So the question we are here at KCD Munich, right? This is a hardware technology. How does this apply to my cloud-native workloads? Where does it fit in the stack? How would I use this? And now we get a bit more hands-on, a bit more practical. And in particular, I want to look at a concept called confidential containers that applies this idea to my containerized workloads. So if you think about the Kubernetes stack, right? We have our cluster, we have our nodes. Usually in the cloud, our nodes are virtual machines. So our control plane as well as our worker nodes, they are virtual machines. And inside, we deploy our application usually in a containerized form. Now, the question is, we have a virtualization-based isolation mechanism, right? We can apply this to a VM. How can we apply this to the stack? And last year here, I presented a concept where we actually take the first thing that comes to mind is applying it to the VMs, right? We have a VM isolation. We have VMs at the node level. There's a match. Let's do this. And what we end up with is what's called a confidential cluster. So every node in that cluster runs inside its confidential VM, and it's isolated as a whole. Not going to go into the detail. I think the takeaway here is that this gives us with a very good isolation, a good one-to-one abstraction. The problem is maybe that you cannot shield inside that cluster, so you cannot have this strict tenant isolation inside the cluster, and as the cluster is isolated, it's also isolated from the service provider, so you need to maintain and operate your own cluster. The other side of the spectrum, and this is what we focus on today, is if we just want to apply this to our workload, just to our containers, and we want to operate this inside any potential Kubernetes environment. You see a lot of red boxes because this means we don't trust our control plane. We don't trust our worker nodes. We only trust what runs inside this isolated environment, which is gatekept or protected by the CPU. And what we want to do is we want to apply this to our containers. So the first problem we need to solve is this mismatch of abstraction. VM isolation, container workload. Therefore, and don't worry, we're not going to go into all the details, just that you get the idea. If we take a look at containers, and this is highly simplified, right? If you take a look at the container runtime path and so forth, usually we isolate our workloads inside Linux namespaces, control groups, these mechanisms to create what we call containers. There's already the idea to, instead of using namespaces and control groups, to use VMs, right? This exists in, I don't know, Amazon Firecracker or Kata containers. Kata containers is a CNCF project that takes the idea of running every container inside its small micro VM with the goal of protecting more or less the host from that container, because you have a stronger form of isolation. It's harder to break out of this VM than it might be to break out of the Linux namespacing. So Kata containers already does this idea, run every container in its own small micro VM with a small microkernel, some agent code, and then our container image inside. And this solves our problem. This solves the problem of how can we fix this mismatch in abstraction. Because if we apply this VM isolation, we can run every container its own confidential VM. And this was started as a project out of Kata containers, and it's now its own CNCF sandbox project called Confidential Containers, which provides us with a Kubernetes runtime for running every pod inside its own small confidential micro VM. And this supports all of the hardware vendors' solution. This is a community project. We are part of this, but a lot of bigger players are in the ecosystem support this to have this Kubernetes runtime. All right, so this solves our first problems, provides us with the primitive to isolate our containerized workloads with this hardware-based features of confidential computing. Question is, how do we get started? How do we get hands-on? How do we use this? And conceptually, let's assume we already have an application. It's already containerized, and it already has a Kubernetes deployment. Let's think YAML files, Helm charts, whatever. And we have a cluster that's capable of running confidential containers. What does it mean? It runs on top of hardware that supports these features. That's the latest AMD CPU or Intel CPU. So what is necessary? Usually we just provide this information or container deployment file or Kubernetes deployment files to the cluster, to the API server, and then the magic happens and our application is scheduled and running on these Kubernetes nodes. So what do we need to do to use confidential containers instead to isolate our pods? What we need to do is we need to change the container runtime. We need to tell the deployment, hey, please don't use the regular container runtime, use this confidential containers runtime. And we need to, of course, install that in the cluster. And once we do so, all of our containers end up running inside their own small confidential VM. The question is that all we need? What did we gain? Right? Think back to the original problem statement. We want to run sensitive workloads. What did we achieve here? And the missing link here is we passed everything through this API server. So everything went through, think of the red boxes, right? Everything went through something we potentially don't trust. The API server, the control plane, assume a managed Kubernetes cluster in the cloud, I don't know, in Azure AKS, right? This is something that's provided by the cloud provider. And we pass everything to the cloud provider and tell, hey, please run it in an isolated environment. So we trust the cloud provider to do so, but we didn't verify that. And this is the first thing we need to do is we need to verify. And confidential computing has a neat property, which is called remote attestation. So we can go to any of these green boxes, and inside, what's running inside, it can ask the CPU to provide it with a cryptographic proof about its identity and the fact that it runs inside a confidential VM or a confidential container. And we can go now to every of the green boxes and ask them for their attestation statement, and we can verify this attestation statement and verify, first of all, right, the integrity and the confidentiality of this environment, and we can also verify the identity of what's running inside. This is the first problem. And once we did so, right, we need to then, of course, also ensure that our Kubernetes control plane does not have access to these green boxes. Because usually the container is not its own island that lives on its own, right? It's communicating through the container runtime, through the kubelet with the API server, and there are certain API calls that you can do. Think of like a kubectl exec would be a very pragmatic example. If you do kubectl exec into one of these green environments, you essentially broke the isolation. So a lot of these problems just occur because we run in this thread model, we run in an untrusted environment because we don't trust the underlying stack. We don't trust the Kubernetes. And this goes further if we want to think about how do pods communicate. So if one pod communicates with another, how does it know that it's also inside a green box, also a confidential container, and is isolated from the environment? So these are just questions that occur that we need to solve, which are fundamentally because we don't trust our Kubernetes environment. And yeah, we were dealing with this problem, and we created a new project called Contrast, which you can find on GitHub. Contrast is somewhat like a toolkit, a framework, an open source tool for deploying an application inside confidential containers, doing this verification part, verifying the integrity and identity of all of these containers, providing a mechanism to isolate them from their Kubernetes environment, and then somewhat like a management toolkit that we use for operating confidential containers. So what does it look like if we go ahead and we want to do this deployment with confidential containers? And I want to give a practical example. Let's see if it works. So this is the documentation of Contrast. Let's assume we have this confidential emoji voting application where you can vote your favorite emoji, and because this is highly sensitive information and you don't want to be leaked what's your favorite emoji, we can deploy this in a confidential mode. And this application consists of, it's a very basic microservice application. It has just a web front end and 2 back-end services. They are containerized. There are deployment files for this. And all we want to do is deploy this inside confidential containers and verify that everything has integrity and confidentiality in the end. The first thing we need to do with Contrast is download the CLI tool and download this deployment, which we can do from the GitHub. And I've prepared an environment over here where I have an AKS cluster, an Azure Kubernetes Service cluster that is confidential computing ready, so it has the right hardware, it has the features to deploy confidential containers. And I already downloaded this application. So the first thing, let me get back to the slides. The first thing we want to do is we want to take care of this attestation part, right? Or maybe I start one step ahead. The first thing we need to do is get to this state, deploy the application in the sense that we need to change the container runtime, and we need to apply this container runtime to all of our deployment files, so all our pods are ending up in these green boxes. And this is the first thing we can do, is we can deploy the container runtime. And this is provided as a YAML file in the release. So all we do here is install an additional container runtime that is based on Kata containers and runs our pods inside confidential VMs. And the second thing we do is now, let me unzip the application first. This is the deployment file of the application, and I already in this demo application, right? So you find these different services, the web front end and the 2 back-end services. You find their description here, and down here we changed the runtime class, the container runtime class. Let me increase the font slightly. We changed this to the Contrast runtime class of this release. This is something we did, and then we end up with this picture here, where we have all of our pods running inside these green boxes. And now we come to the verification part. So the verification means we need to verify all of these individual containers and ensure they are indeed running inside their environment, and they are indeed the containers we expect to be running there. And in Contrast, we want to do this in a scalable way, and therefore we install an attestation service. Think of like a trust anchor. We can verify that we can trust this trust anchor and establish trust in this trust anchor, and this then takes care of verifying all of our pods depending on how this scales and whatever it looks like. So we just do this in a scalable way, in a transitive way. And this is the second step for this demo, is that we install the attestation service, and the attestation service is called the coordinator. We just install this as a deployment inside the cluster, and this attestation service itself runs inside a confidential container. So we can verify it through this remote attestation feature and provide it with the information that it needs to verify all of our other containers during the runtime of this deployment. So this provides us with this step. So we installed the attestation service. And now the important part is isolating all of these containers from the Kubernetes runtime, from the Kubernetes API control plane. And there we use a concept that was established inside the confidential containers community, which is called runtime policies. Essentially, what this means is we take our deployment files and we synthesize a policy that checks that all of these properties that we specified in these YAML files, that assume or think about the environment variables, the mount points, the container image, that all of these properties are correctly applied to our confidential container, so that the API, the API server, the kubelet, whatever is in between us and the deployment, cannot modify any of these values. And we know that whatever's running inside the green box has the integrity and adheres to what we specified in our deployment file. And this happens through synthesizing a policy from our deployment files and enforcing this policy through an agent inside the confidential container. And this is the next step in our deployment, is generate those policies and provide those policies, first of all, to this agent, and in a second step also to the attestation service. So let's first synthesize these policies. And we can see that in this step, we do also two things. We inject an init container, or we inject two init containers here. One is responsible for doing this attestation part, talking to the CPU, obtaining the attestation statement, and being able to verify its integrity and identity. And the second thing is a sidecar container that is responsible for pod-to-pod communication. We'll see this later on. All right, we synthesized these policies. These policies are also annotated in this deployment file. The annotation is pretty much how this policy ends up to the confidential container, and the agent inside is picking it up from there and then enforcing the policy throughout the lifetime of this container. And we synthesized a manifest. A manifest just bundles all of the policies, all of the containers that are part of our deployment. You remember the 3 microservices. They all have a corresponding policy, and they have been synthesized from our deployment. And this manifest is provided to the attestation service, and the attestation service enforces this manifest, this policy, throughout the entire deployment. So what we have to do next is set this manifest to the attestation service before we can roll out the deployment. So just picking up where the attestation service runs, and then we set the policy. Oops. Yeah, of course, the demo gods have struck me. I'm not going to debug this now live on stage. So yeah, usually I would just set the policy, set the manifest here, so that the attestation service knows what to expect to be running in the cluster and verifying all of these individual pods. And then I can roll out the deployment. Inside the deployment, the init container comes up. It connects to the attestation service. It gets verified on its identity, or they get verified on their identity, and they get become part of our confidential deployment. The attestation service serves them identity credentials, which makes them part of this service mesh, and then they can communicate securely with each other and be isolated as a deployment from the Kubernetes cluster. All right, so this was very hands-on, very practical. But in the end, what we end up with is basically that we can verify our entire deployment through this attestation service. We know that our deployment is protected from the Kubernetes control plane through this runtime policies and the enforcement of these runtime policies by our confidential container environment. We can skip that. So summary, what did we see? We saw that what confidential computing is, what's the idea behind it, how does it work in terms of being a hardware-based technology to encrypt and isolate our workloads, our data, while it's in use, while it's being processed in the cloud. And this fundamentally changes our threat model in the public cloud, where we can keep the cloud service provider, the infrastructure, out of our trust boundary and only trust our workload and the hardware, the CPU, as the gatekeeper, as the enforcement of this isolation. And this becomes very interesting when we talk about regulated industries, sensitive sectors that need to ensure that nobody can access the privacy-relevant information of what we are running inside the cloud. And we can really reduce the trust in the cloud to the hardware itself and don't have any third party, such as the service provider, inside the trust loop. We saw how we can do this in practice, how confidential containers can bring this to the cloud-native level, and how we can go ahead and deploy confidential container deployment from an existing deployment using contrast, or we almost saw it if the demo gods would have been with me. If you found this interesting, I think contrast is a great place to start and get practical hands-on with this kind of stuff. The confidential containers community, as I said, is part of the CNCF. It's a sandbox project, and you can find everything also on GitHub, all the meeting links and all of the documentation. So if you're interested in the confidential containers, this is also a great place to start. And I think these are the two places I would point you at for further information. Yeah, thanks very much, and happy to answer any questions.
Firstly, great presentation. Thanks a lot. I have one question. In terms of the encryption, are you using homomorphic encryption to achieve the confidentiality, or are there other methods which you're using there?
So it's not homomorphic encryption. The memory pages are encrypted with usually symmetric encryption, so AES.
Okay.
So all of the memory pages are encrypted with AES, and the CPU takes care of who can access the memory pages. And if I'm the guest, if I'm inside the green box, I can just access the memory page and read the content as it would be plain text. So if it's loaded in the CPU and registered, it's decrypted by the memory engine, and I operate on the plain text data. And while it's inside the CPU takes care no other context, right? No other kernel or VM or whatever can access the registers at runtime.
Okay, understand. Thanks.
Thank you for your talk. I have a question about this attestation service. What happens when the verification fails? So does the container get restarted, or does it get deleted?
From a container perspective, the attestation is done by the init container that we inject. Mm-hmm. So the init container will fail and will be stuck in the initialization period.
Okay. Yeah. Thank you.
Sure.
Yeah, so my question also goes to the Azure service. Is that deployed by every application team? So every team that sets up their application on these pods installs their own assertion server or service?
Yeah, the attestation service can be played in slightly different ways, but usually it's one attestation service for one deployment that needs to communicate with each other. So everything that should be under, like, let's say, one should be isolated as one, should be under one attestation service. But it can be namespace. You can have multiple attestation services per cluster. and usually it's attached to the deep deployment. Yeah.
And how is it asserted itself? So this initialization that was also, so how is the assertion of the assertion service done?
Okay, yeah. The attestation service is fundamentally only also a deployment, a service inside the cluster, and it's running inside a confidential container as well. And when you set up the things, when we set the manifest under the hood, this confidential container is verified through a remote attestation procedure. So we know there's actually a confidential container running, and inside there's actually the attestation service image running. And thereby we establish trust in this attestation service.
Question regarding the access of the hardware. If I use the hardware for the confidential parts, does that imply that I have to run the Kata containers directly on the hardware level?
Good question. So Kata containers, and in specifically confidential containers, can be done in three ways. Either it's a bare metal machine directly on the hardware, then I can just create VMs on this bare metal machine. If I have a virtualized environment, there are two options. Either I do this in a nested way. I create a nested confidential VM inside my host VM. Or if nested virtualization is not available or not desired, the alternative is called remote hypervisor or peer pods principle, where I basically create a confidential VM outside of this as its own dedicated VM, and then I just forward the traffic and everything back to my host and my node. This is depending how you want to see it, either a workaround or a desired way of not being dependent on nested virtualization. Any more questions?
Okay, I would like to ask a question. I'm a volunteer. Initially when you mentioned this compliances, so the DORA which you talk about, okay, the encryption must be in use. So my question is, like, when I do this for the pods, then I don't need to worry about any other thing. Let's say, for example, privilege escalation. So my container, everything is pod even in use. So should I be not worried, or still I should have some more tools to, let's say, the vulnerabilities and all this cloud configuration and all these things?
Good question. So confidential computing adds a layer of isolation, right, between the hardware or the service provider and us. It's not solving all of the security problems. Right? So the container image still does things, right, and it could still contain vulnerabilities on the application level that would still need to be addressed, right? So this is an addition. It's not just because you're running, let's say you run it encrypted, you run everything encrypted, does not mean you don't need to worry about the additional or the current security questions. Yeah. So, and in terms of additional security, right, you need to be careful about what's running inside this confidential container, how is this microkernel built up on, and so forth. Yeah.
Okay. We have one more question. Thank you very much, by the way.
Sure.
How is the availability in the public cloud providers today? Do they all support this?
Yeah, so the hardware infrastructure, so the AMD and Intel chips, all hyperscalers have them. They all have it as infrastructure as service. They all have confidential VMs that you can book as an offering. And beyond hyperscalers, in Germany, for example, Stackit has it. Some European clouds have it. And then in terms of confidential containers, as the previous question was, this either requires nested virtualization. This is only supported by Azure right now. Azure has built nested virtualization for their Hyper-V hypervisor. And in the other clouds, as is GCP or AWS, you would need to do this remote hypervisor principle. And yeah, in the confidential computing itself is generally available with all major clouds. Okay.
I believe no further questions.
All right. Thank you very much again for listening.